All right, we're back. We're on page 10 of notes 14 of Calc AB. We're just doing review problems. Do they have anything to do with what we just did? I don't know, maybe, but it actually kind of doesn't look like it. It's really important. I mean, calculus is kind of like a different beast from what you're used to. You got to remember everything all the time. Like, you never know when a problem is going to call for something that you learned, I don't know, like in May of last year or September of this year or whatever. Like, you just got to know all of it all the time. So, and that's different. Like, it's hard to get your mind around that initially. So let's see if we can do these. So we are given f of negative 2 is 6, f of 6 is negative 2, f prime of negative 2 is negative 3, f prime of 6 is negative 1. All right. Equation line tangent to g of x, where g of x is f. All right. Tangent to the inverse at x equals 6. All right. So what point is on the inverse? So x equals 6 is for the inverse. So on g of x, we have 6 comma. All right, so what you do is you go up here and you look for 6. This 6 is the same as this 6. It's a y value for the original function. So on the inverse, we actually have the point 6 comma negative 2. So then the slope, g prime of 6 is going to be 1 over f prime of negative 2. F prime of negative 2 we can find here. So f prime of negative 2 is this. These problems always give you like a little bit of extra information because they have to try to trick you to see if you know what you're doing. So like, feels like a jerk move, but they basically have to do it. So the tangent to g of x at x equals 6 is going to be y minus negative 2. So y plus 2, negative 1/3, x minus 6. There you go. All right, that's a really, so free response question, multiple choice question, typical. You will see that. I feel that you will see one question like that either on the free response, like one little section of it, or multiple choice. All right, evaluate each of the following integrals. All right, so we can do these however you want. How do I want to do them? I just want to like get them done. So this problem, I look at it and I think there should have been so there should be a 5 here by the chain rule. So I'm going to put in a 1/5. And then this is to the 1/2. So add 1, that's 2/3. And then 5x minus 3 to the 3/2 plus c. So let's simplify that. 2/15, 5x minus 3 to the 3/2 plus c. You could do, obviously, just do u substitution. U is equal to 5x minus 3. Then 1/5 du is dx. And you have 1/5 the integral of u to the 1/2 du. And then add 1, you get u to the 3/2. The reciprocal is 2/3. 1/5, 2/3 u to the 3/2, which is exactly what we have. 1/5, 2/3 is 2/15. So I think we got it. All right, so the question here is this going to be arctan or is this going to be natural log? So my first thought is I hope it's natural log because it's a little easier to deal with. So if I make u equal the denominator, then du is 72x dx. And that works. I need a 72 and a 1 over 72. So this is 1 over 72, natural log, absolute value 1 plus 36x squared plus c. So basically I'm saying u is 1 plus 36x squared. I feel like this is like a trick question though, because so like, am I right? 72x dx. Yeah, 1 over 72. And then you just get du over u there. Do you need the absolute value on this? You don't, because 1 plus 36x squared can never be negative, but it doesn't hurt to leave it. So that's what I'm going to do. But it does not hurt to leave it. It doesn't hurt to get rid of it. It doesn't hurt, no matter how you do it, honestly. So I'm going to do these and then check them, I guess, on the calculator. Okay, so I look at this and I'm like, all right, that's definitely u. So if that's u, there should have been a negative 13 up here, but there's not. So I'm gonna balance it, negative 1 over 13. And then it's like u to the negative 1/2. So plus 1 is to the positive 1/2 times 2. So it's 2, 8 minus 13x to the 1/2 plus c. So then this will be negative 2 over 13, 8 minus 13x to the 1/2 plus c. Do your u substitution. U is equal to 8 minus 13x. Go for it. I'm going to check them on the calculator at the end, but feeling okay about it. Here, is it, this has got to be natural log. It's like the only choice. I'm going to make u equal this. So then the derivative of secant is secant tan. So this is perfect. It's already done. Natural log, absolute value, 1 plus secant of x plus c. So how did I know to do that? What else are you going to do? I'm not going to make this be u because, like, why would this, then what do we do with that? So in my experience, denominators are good choices. And when I took the derivative of the denominator, I just got the numerator. So I knew this was, basically this is du over u, which is another natural log. Definitely I'm leaving the absolute value there because secant, the range of secant is, you can go to negative infinity. So like that could be negative. So I think we should do it. This one, definitely need to do work on because offhand, I don't know. So u is radical 3 minus x. You could make it just 3 minus x. I think the better choice is the radical. So u squared is 3 minus x. I'm going to add x and subtract u squared. 3 minus u squared. So that's x. So dx is negative 2u du. And so we have substitutions we can make. So x is 3 minus u squared. The radical thing is u. And then I'm going to pull the negative 2 out. Get u du. And then we expand negative 2, the integral of 3u squared minus u to the 4th. This one's going to be a pain to check. I can feel it. So negative 2, u cubed minus 1/5 u to the 5th, because the calculator is going to factor that. And then u is, I'm going to say 3 minus x to the 1/2 so that I can rational exponent this thing. And should I also distribute the 2, the negative 2? Evidently I should. 3/2 and then plus 2/5, 3 minus x to the 5/2 and plus c. I like doing review questions. You'll find, if you're in my class, my favorite part of this class is reviewing for the AP exam. Also, if I lean in, oh my God, the sun is like, I never really make videos at this time of day. I didn't even realize, I can hardly even see the iPad screen. It is just like lit up. I feel like I don't actually think the sun can come around the corner enough to like hit my face because I don't know what kind of turn it would need to make, but like, whew. I mean, I could also be wrong. All right, I'm gonna say that u is this. So then du is 1/2 that to the negative 1/2. So there should be a 1/2. So I'm gonna say this is 2 sine of radical x plus c. So if you need to do work, u is equal to radical x and go to town, but I'm pretty sure that's right. Yeah, I'm pretty sure. Feeling pretty good about that. I think that's good. All right, we will check those at the end, but I don't want to make you hang around for that. I don't want you to hang around and see if I actually got it right. All right, for all values of x, the slope of y equals f of x is this. This is a weird way. They write questions like this a lot. So this is just saying f prime of x is 2x minus 3. It's like, how do you get to this point in calculus and get thrown off by that? I don't know, but like, I guess people do because it's a really common type of question. So then I need to find f of x. So then f of x, I'm just going to do it, x squared minus 3x plus c. We know f of negative 3 is 4. So 4 equals 9 plus 9 plus c. So c is negative 14, I think. So f of x is x squared minus 3x minus 14. Yeah, reviewing is fun because like you just get like random questions thrown at you and you get to really like, I feel like that's when you really internalize things. Particle moves with velocity 6 minus 3t. The particle is at 5 when t is 0. Find the next time the particle is at 5. Okay. I mean, I can think of 2 ways to do this. I'm going to do it like, I'm just going to find the function and say, so x of t, I'm going to integrate the velocity and solve for c and then set it equal to 5, I guess. So that'll be 6t minus 3 halves t squared plus c. So 5 is equal to c. All right, well, that was 6. X of t is 6t minus 3 halves t squared plus 5. So I'm going to set that equal to 5 and try to solve. I know one solution is 0. So 5 equals 6t minus 3 halves t squared plus 5. So you end up with just 6t minus 3 halves t squared equals 0. You can take out, you can take out stuff, but I'm just going to take a t out. 6 minus 3 halves t. Like, you could have done something with those coefficients, but like, why bother? T equals 0, we knew. And then t equals, subtract 6, divide by, what? 6 times negative 2 is, I don't know what I'm saying. I think the answer is 4. I mean, it definitely is. Negative 6 times negative 2 is 12. Divided by 3 is 4. That's what I was trying to do. That's the next time. So it's a lazy answer, but I'm just gonna highlight that. T equals 4. That's the next time. All right. Do we want to check some or all of this? Let's go. So I'm gonna go to I'm checking on the calculator. Here we go. So new document. Start clean. I'm gonna do the integrals. Integral. Bad start. Integral square root of 5x minus 3. What is this? Square root of 5x minus 3. 2/15. Yes. Integral x over 1 plus 36x squared. This one I think is natural log. If it was 1 over 1 plus 36x squared, it would have been arctan. So this we got right. If we change this, so then it would be 1/6 arctan of 6x, I think. Yes. So maybe try that one, see if you can do it. Always be thinking about that. Natural log and arctan, like, ooh, fine line, fine line. Integral of 1 over the square root of, I feel like my laptop really doesn't appreciate getting blasted by the sun here. X negative 2 over 13, and then radical 8 minus 13x. Got it. Integral. Calculator really doesn't like giving answers in terms of secant and tan, so I don't know what's going to happen here. I also don't know why I'm using t as my variable. I think I was saying tangent at the time. So this, I got natural log of absolute value of 1 plus secant. Holy cow. Let's do this. Derivative of natural log of 1 plus secant of t is tangent over 1. Okay, tangent over that. Tangent, if I multiply by secant over secant, I get secant tan over secant times cosine is 1, and then secant times 1 is secant. So yeah, it's right. Sometimes you got to do weird stuff to like match your answers. This one, I think it's not going to look like what we got, so I don't even know why I'm bothering here, but yeah, that doesn't look anything like what we got. So let's say, let me type in what we got. Negative 2. Let me do this. Negative 2t cubed, and then plus 2/5 t to the 5th, such that t equals the square root of 3 minus x. Are these equal? I don't know. Does this equal this? Those aren't equal. So did I type it in wrong? Negative 2t cubed, and then plus 2/5 t to the 5th, square root of 3 minus x. Arg. All right, let's try another method of checking. I'm like pretty sure it's right is the reason that I'm checking so much. If I do the integral of x times square root of 3 minus x with respect to x, and then I'm also going to type in our answer, which was negative 2, 3 minus x to the 3 halves, and then plus 2/5, 3 minus x to the 5 halves. And then there's like a plus c that can mess it up. They're the same. I don't know what's happening on the calculator page. Like I literally don't know. And if I'd factored it, it probably would have been easier, but I didn't factor it. So back to the calculator page. Integral cosine square root of x over square root of x. This has like all kinds of domain issues. 2 sine of square root of x. Good job, us. I'm going to use differential equation solve, which is like menu 4 up a bunch of times. And then it's x prime is 6 minus 3t, comma, t comma x. Oh, wait, I have to do an and x of 0 equals 5. So negative 3 halves. I don't know what problem I just did. Oh, I just did the last problem accidentally. Did I? Oh, and then I need to solve answer for t such that x equals 5. 0 and 4. Okay, that's good. I meant to do this problem, which is, this is the problem above it. Y prime equals 2x minus 3 and y of negative 3 equals 4 xy. Yeah, that's the answer we got. All right. So checking them can be an issue. Like it's not necessarily, I don't, why is my mic's not working? Is my mic not working? What is this? Hello. I think the mic's not working. Oh, that's going to be a tragedy if that's what's happening here. It seems to be indicating that the mic is not working. I don't know what that would mean. So I hope it's working. I don't know. All right, anyway, I'm going to end this here. I'll be back maybe to re-record this if there's no audio. Oh, that'd be so disappointing. Anyway, I don't know. I'll see you in the next set of notes, or I'll see you when I'm re-recording this and you don't even know, except I'll probably complain about it a lot. So one way or the other, see you in the next video.